Hi everyone, welcome to Operations Management course. In this lecture, we will learn Statistical Process Control Chart. This is the second part of Statistical Process Control Chart, and in this lecture, we will be learning about the mean and range chart, how to calculate and visualize them. Here's the third topic, that is mean and range charts. A non-manufacturing example of mean and range chart would be the tracking of temperature of a patient in a hospital like this. This figure shows how it is changing. It is important that a patient temperature stay within a safe zone. A normal body temperature is 98.6 Fahrenheit degree. A temperature above 100.4 Fahrenheit degree is considered a fever. Care providers measure and chart vital signs, including temperature on a regular basis, and they should be able to tell if the person is staying healthy or going out of control. So then let's think about how to draw XBar chart. There are two cases, however, let me just go with when sigma is unknown situation too. There are different types of chart available in SPC. As I mentioned, it's either XBar chart or R chart. Here are the formulas that we can use. These are developed by management scholars, and we can use that. For XBar chart, we have upper control limit, and that is derived by X double bar plus A2 times R bar. And lower control limit can be derived by X double bar minus A2 times R bar. And here X double bar means that it's mean of the sample means. There are many samples, many means, and mean of the means is X double bar. And R bar is the average range of the samples. We have a sample and calculate the range and average them together, and that's going to be R bar. And A2 is control chart factor found in table S6.1 in your textbook, and I'm going to also show it to you in the next slide. Here is the table. So this table was proposed by management scholars, and we use this when the sigma is not known. And A2 value, which is mean factor, can be found on this table. In this table, it's important for you to refer to the right sample size. So sample size is important, and you just need to read corresponding value. It indicates the number of processes that you have examined, you are examining. In other words, if you have one process, the sample size is 1. If you have 4 processes, then the sample size is 4. Say you have 4 production lines, then the sample size will be 4. And say you have, in a bank, you have 10 clerks who are helping out customers, then that's your sample size, 10. So depending on the sample size, you will read corresponding mean factor A2, and that's going to be your A2 value. Similarly, later, when you are calculating R chart, you want to find the D4 and D3 values and read them that are corresponding to the sample size. Say you have 4 processes, and D4 value for that will be 2.282, and lower range would be 0. So let's go to R chart. For R chart, we need to use a different formula. For upper control limit, that's D4 times R bar, and lower control limit is D3 times R bar. Here R bar is again average range of the samples, and D3 and D4 can be read from the previous table. Here let me take an example. That's a GM Chevy Volt production, and I created this data myself. Say we have three production lines. So GM Chevy Volt are being produced in three lines, and this is a fictitious situation. And it starts at 9 o'clock in the morning, and you measured the number of, say, Chevy Volts were created, maybe 10 of them in line 1 between 9 and 10, and you found that their average miles per gallon is 200 mpg. And you did the same with line 2. So between 9 and 10, they had 10 cars produced, and then mile per gallon was 210. And then line 3, it was 185. So, depending on line, we see that line 2 performed better than the other two lines, and line 3 performed the worst at this time. So we can see that line 2 is the benchmark in this case. And between 10 and 11, we see similar situation where line 2 was the highest performing production line, and line 1 and 3 are doing similar, and they improved much better, especially line 3 improved very well. So likewise, you measure the miles per gallon per each hour like this, and then calculate the mean of the means, here 180, 170, and 240, and so forth, and you did that until 5 p.m. And the question is, I want to know whether this process is in control or not. When you are doing that, you have to always think that, oh yeah, I need to calculate both XBar chart and R chart and project them and see if both of them are in control or not. And even if they are in control, you have to read the patterns of those dots and see whether they are doing well or going out of control. So let's first work with XBar chart. When sigma is unknown, you are going to use the table that I introduced you before, and you're going to use the formula that I gave you. So here, I just entered all the data into Excel sheet and calculated XBar. XBar was the result of line 1 to 3, and it came out right here. So if you add them up, then divide by 3, then you will have XBar 198.333. And similarly, you can calculate R. R is range, so it can be calculated by maximum minus minimum. For example, 210 is maximum, and minimum is 185. So if you subtract 185 from 210, you get 25. So in this way, you calculate XBars, or mean of means, means, continually here, then, and go down there, and now you can calculate X double bar. X double bar is the average of means, so you add this up and divide it by number of samples, which is 8 here, right? So we have 8 and divided by 8, and you got 202.708 miles per gallon. In range, you have that, and you found that the range was on average 24.375. Once you calculate this, now you can easily calculate upper control limit and lower control limit together. So let us use this formula for upper control limit, XBar chart. We know we have to use this formula for R chart below formula. And using Excel, I calculated them. So 6 sigma level and A2 1.023, because we have 3 samples. Let me go back for you. 3 samples, and A2 value should be 1.023, and D4 should be 2.574, and D3 should be 0. So that's how I got those values here, and then I just plugged this formula into Excel and calculated them and found the answer here, and then I'm going to see what is upper control limit and lower control limit, and I projected that here, and I have upper control limit 227, lower control limit 177 here, and the center line is 202, right? So I draw the lines, and it looks like XBar chart is under control because it's within the limits. Similarly, I did the same thing for R chart. I used this formula, D4 times R bar and D3 times R bar. We know R bar is right here, 24.375, and D4 is 2.574, and D3 is 0. We did that. And upper control limit for that is 62.74, lower control limit is 0, and center line is 24.375. So I projected that on this Excel and connected the dot together so it becomes a line graph, and I have center line and upper control limit and lower control limit all together, and I found that here at 11 a.m. It went out of the limit. So the other hours were okay. However, at 11 a.m. something happened and it went out of the control. So as I look at both of this control chart, I can say that this process is out of control because although XBar chart was under control, RBAR chart was not under control due to that spot right here. So the question is this good problem or bad problem? The answer is this is a good problem, because if you go back to 11, what happened? So let's go back to the data at 11. So 11 to 12, what happened? Line 1, 180 miles per hour, line 2, 170 miles per hour, line 3, 240 miles per hour. So suddenly, line 3 soared. It has done a really good job. I don't know what they did, but suddenly they produced this Chevy Volt so well that the mileage per gallon increased drastically, and as a result, 240 miles, the lowest one is 170, and it gave you 70. So if it would have been a bad problem if line 3 produced 10 cars and its mile per gallon is 100, then it would have been really bad problem. However, in this case, they improved their productivity and miles per gallon became much higher than before. So it looks like line 3 did something very well, or they measured their statistics wrong. That's another possibility. So if you are the manager of this production line, you will say, oh wow, what happened to line 3? And what about line 2? Suddenly from 215, it just tanked to 170. What happened? So you want to go and visit and talk with the operations manager or production people and see what happened in the line at the time. And doing so, you can find out the reason. For example, say line 3 did something really something good and right, then you want to learn from that and try to replicate the result there. So in this lecture, we learned about XBar chart and R chart, how to calculate them using the table provided for you. Thank you.